Hey everybody, let me start off with showing how majestic I am. Oh yes. Ah man, I tricked you into that one, didn't I? Okay. Part 16. Yes. Okay, we made it past the hump. Part 15 was the section that took 6 months to do. Well, part 16 fast forwards 2 months. And now I am on holidays from work and I've got the bug again. And this time around, I am checking out the bitmap, looking for ways to save time with it. And it's interesting in a theoretical way. Like there's not much flash, there's not much of me, running the program. It's looking at data, coming up with ways to squeeze some performance out of it. And I've trimmed down some of the fluff, and it's still a pretty lengthy episode, 20 some minutes long, but I find it interesting. And if I find it interesting, well, I can't really cut that data out. But this part and the next two parts are pretty much a lot of theory. So if this isn't your cup of tea, I do apologize. But it is a big part of what this project has become. At the moment, I guess the last mile is looking for these ways to squeeze a bit more out of 93% because I cannot surrender at 93, not after this length of time. So yeah, come with me. Let's see how it goes. And yeah, part 16, compressing time. Let's watch. All right, it has been a long while. So what have I done? Well, a lot of nothing. But I had an idea, and I chased it today, I guess it was today. Anyway, look at this. What happened? It read off the BackBit here, it read one 32-page chunk of a frame of the video I hope to compress. There. Now, 301 of the 992 cells that it examines, because it only looks at 31 pages, start with a 0. 13 of those cells start with the value of 1. Okay. Now, if we look at 2, the repeats, that's it. Oh, and here's where the savings lies. There's only two values, 0 and 85, where they are repeated for the entire cell. And those are the amount of occurrences of each. Now the trick is that is in the raw bitmap data that's read from the BackBit and put onto the screen. How do I compress it? But you don't want to compress it. This isn't about saving memory. It's about saving time. So I needed a way to, on the fly, read it back and know that it's compressed in a way that it can splat it down faster than just read a byte. And so what is number 4? Not first. It's kind of the opposite. These are the ones, now this is where I started to get an idea. Not first is the ones that are zeros, right? Like number 6, the value 6 never appears anywhere as the first value of any of those bitmap cells. Okay, this time I have the super CPU running because it is going to take a lot of work to analyze this. The quickie part, you see a little blurb at the top, it is tallying up the frame read from the BackBit, just the bitmap data. And what are all these numbers? These are the ones, well, this is the value, this is the amount of times that it has appeared in as the first value, the first byte of each cell, checking out 992 of them. So you look, frame 13, frame 14. So as time goes on, if, say, the value number 50, if a 50 appears at the top line of any of these cells in any of these frames, it punts it. You're the weakest link, goodbye. It gets rid of it. And what I'm doing is I'm whittling down the choices because I want to use the very most rare value as a flag saying whatever's next is a repeat of 8. And then they can just go boom, 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 and without having to read it from the BackBit, So it will save a few cycles and those add up. But the thing is, there is 933 or something frames in this little video. But eventually, see, it looks like 211 is the winner, right? But it's really not, because eventually that will disappear as well. Too bad it didn't, because had it remained at 0 throughout the entire file, I could say, you know, load first byte of cell, compare with 211, and if it is 211, that is our flag to take the next byte and splat it down 8 times in a row, real fast. Now, that's a good idea, but eventually it's going to disappear. Now, I think it disappears at around 100. I also added a way to bring back the most promising candidate. Now, all I have to do is press a button here, but there we go. Let's press it again. Now it's increasing the ones that it's willing to accept. See, let's raise the tolerance even higher. I can only do it 1 per run, big deal. There, we'll make it 5 for now. So these are the current candidates. Now, as you see, like, well, the phone is having a great old time trying to focus on this, but 178, for example, there it is. It appears twice. So out of 167 frames, 168, the value 178 only appears twice as the top cell, like the top byte in one of the character cells. So 176 times almost 1,000. So in 178,000 cells, the value 178 appears 3 times out of 178,000. Now, so what's so big deal about that? Well, I can use 178 as my compression flag, but as you can see, it 3 times out of whatever, it is actually a legit 178. I can add some complexity to check for that, but that's complexity equals time. We don't want that. So I have 2 ways about this. The first simplest way is simply go, if it's a 178, treat it as compressed. In the cases where the 178 is a true 178, what it ends up doing is reads the next byte and repeats that 8 times. And it may not be the desired picture. It may corrupt one cell as a solid block or a stripe or something repeated that it shouldn't be. But out of 992 cells that it affects in a frame, out of 178 frames, you'd have to be watching like a hawk to notice it, unless it, you know, is like a sore thumb of white in a sea of black or something, but I don't know yet. The other idea is analyze the entire frame, and I'm certain in every single frame, at least one of the cells, and as you can see, many of the cells actually appear as a 0, probably a handful, like maybe 40 or 100. So you just pick one. And where do you put that magic byte? Well, the last 192 bytes of the bitmap are isolated. So, like, they're zeros. So just put it as the 65th byte of, you know, that final row. So read the last row, uncompressed, grab that single byte, plunk it into the self-modifying code, and then read the 31 pages, and boom, you'll never see a block that shouldn't be there, even though the data is now actually corrupted in the tiniest way by changing certain bytes, right? So whether you played it, if you played it with the non-compression looky-loo, the way it is now, you might notice the occasional, actually many, because it would be a flag for every single one that has a repeated pattern. So you would see these little blits all over oh, look at that. You would see these little ticks all over the screen. So you need the code that, well, this code. You would need the code that checks for the rare and jumps over here. Well, it's not going to look for that anymore. It's just going to load the next one, splat it down 8 times. Yeah. Glorious, isn't it? But the tricky part, I guess, unless I want to remake the BBT every time I screw this up, is writing to the BackBit. I haven't done that yet. I've never written to a BackBit file. It's possible, and it's probably Evie made it as easy as she can, So I got to go in there and on a frame-by-frame basis, write a few individual bytes and repeat that hundreds of times, and I got to get it right. All right, so, well, as you can see, we're almost done. I think I made it stop after the final frame because there is, I think, 4 or 8 blank frames between the video and the, no, there it is. Between the video and the sound data, I just put in a 64 byte gap. So there's our winners. If I wanted to hard code this, 227 is probably the one. Now, 8 times out of 933 frames, one cell will be undesirably corrupted. Unless I do it on a frame-by-frame basis, look for that unique one. And kind of like the color RAM has a background color specific to each frame, I would also need a specific value for the rare byte, the one that you use as the self-modifying code to flag for a compression, a repeat of 8. And the beauty of the repeat is it doesn't need this to mean repeat a 0 or repeat an 85. It just reads the next byte and will always repeat whatever it is. So it'll work for all the values, not just 0 and the 85. The ones that I'm certain are very repeated. Now, why are zeros repeated? Well, that's the background color. In many cases, there's solid chunks of background. And 85 is, in hex, 55. That's why 85s are so prominent in these files, because it's 01010101, which is the second color, like the first of the whatever colors, and then 10101010. Well, that wouldn't make sense, because if the whole byte is 10 repeated, then you would simply just make it 01s and color it differently in the video matrix. Here's another quick and dirty little program thingy-ma-do. Checking out my 2 candidate numbers. I think it's 211 and 227. If it's, I'm looking to see if any frame has them both as the first byte of a cell. And if so, then I can't use them. But my plan is if it isn't one, then it'll be the other. It's funny that none of these frames lately have had it. Come on, show a frame that has one. There's one. I'm in the process of hacking down my little program, and I'm going to make it do the scan and replace. One thing I think I did is I didn't queue up my right pointer, so it just kept writing and writing over top of everything. But at least it starts at 0, so Evie's got it right, because I mean this is all a file, right? But this is where the sandbox of my BBT begins, the area that I can affect from the Commodore. And I pooched it bad, so I can just reload and try again. All right, it's take 2. Jumping right in there with the super CPU speed, because let's power through this beast, load up my Gabu player, and it should play it with a few, well, tons actually, of first cell only artifacts, because at the moment I don't have the code in place to read those flags, but it will just play them if I have it right. That's the first step, is make sure I got the file right. Otherwise I have to go back to the computer, reload the BBT onto it, blah, blah, blah. Okay, here we go. It's me again. Ah, man, I blundered it. I know what I did wrong. The error I noticed last time, I never did fix it. I patched the right pointer, but not the, boy. So I broke out of that early, because let's just see what it does. It's not going to play right. Oh, hey, it does. See all the little corruption thingies? Oh, they're gone. There they are. Any corruption you see is something that's later going to get spit out slightly faster. All of that. It's going to save me about 20 cycles a piece. Isn't that great? I thought I pooched it.
It'd sure be better if she were here.
I know how I pooched it. Okay. What did I do that I have to still... I gotta reload this BBT and try it one more time. But the thing that I forgot to do... Like, yeah, I made these the little repeat flags, but I forgot to save the flag itself, whether it's 211 or 227 on the last page. I looked for it, and if it's already there, I assumed I did it previously and I skipped the saving part. But I'm saving the previous... how does this make sense? Oh, fuck it. Now, as you can see, it's got all the little dashes in the place of repeated data. Now, on some frames like this one, it's doing well. On other frames, there's very little chunks of 8. So my goal was to have this just be a piece of cake and let me slide into a 100% display rate, but I don't think that's the case. It should be close, maybe 98. I haven't even put in the unpacker part. I mean, I can always just reload the BBT and forget the part where I'm compressing it like this or flagging it. But the only problem that I can see at this point is frames where there's very little savings to be had might make the video fall behind enough to have to drop a frame still. I mean, the same thing could possibly happen with my color compression idea, only this was actually far easier to implement. So yeah, I'm going to try that next. Well, I'll try the decoder and we'll see what we get. Because if I run this, it's still going to be 93. Yeah, because this is my old player, right? It has no idea that certain frames or cells are compressed. But I can hack this in. Well, this is actually a printout from months ago, and it was somewhat efficient at the time. I have to make it less efficient to accommodate this, but hopefully the savings will pay off. Okay, I'm going to start playing it, talk over it. I don't have it queuing up the rare value yet. As you can see, sometimes you see the dashes, sometimes you don't, because what I did here is, well, how do I get out of here? There we go. In the case, well, the rare flag is nothing yet. It checks for 211 hard-coded, and if it is, it goes and deals with the repeat. I already put in this little patch that'll look for either one, because I haven't set it up yet, but I'll get rid of 5731. Speed it up, run 10. There we go, we're already assembled. And now it will treat either one of those values as the compressed flag. And you see all the dashes are gone. But in the case, well, yeah, let me turn on the super CPU. Well, yes. There's still bits of interference, but I think it's because of the buffers. Here's what it's doing though. It's dealing with one cell at a time in a loop instead of, like the previous copy was 16 bytes in a row and doing it 16 times to copy one page. This is dealing with one cell, which is 8 bytes, and it's doing it 32 times. And in the case where it's a duplicate, it jumps over here, deals with it as a repeat, and then goes back. But I'm planning to do, if need be, here and here, do 2 bytes in a row. But the setup is a little more expensive because I have to write, well, as it is, to do 8 here and 8 here, that is 816 times 4, 64 cycles of self-modifying code needs to be set up. And that'll be doubled if I have two 8 in a rows, because the extra cost is having to there's 2, 4, 5, 6, 7, 8, 9 cycles to go back. This 9 times 32, no matter what, it'll be 9 times 16 otherwise. So, well, the savings there actually is more than the 64 bytes or cycles that it takes to set up the self-modifying code. So it's definitely going to be a savings to be had. But at the moment, I just want to see what one set of 8 will do. Well, obviously, I'm going to be at 100, or if not close to it at this point, because I've already cheated. Super CPU, right? Well, let's get out of here. I'll slow it down. 98%. That's interesting. So maybe this wasn't a good idea. But now I'm going to run it at slow speed and see what happens afterwards. While this is still playing, I thought of one of the reasons why it's slower, because it compares to 211 and branches if so, compares to 227 and branches if so. So 1, 2, 3, 4, 5, 6, 7, 8, and it's 4 extra cycles per cell. And there's, well, almost 1,000, right? That it's dealing with, 992, yes. So 4,000 extra cycles per picture here that it's spending just checking for the second rare flag, which shouldn't have to happen if I bother to grab it and throw it in the self-modifying code like I plan to. But I'm just hacking it because I want to see this thing work. Ouch. Something isn't working.